Hello and welcome, I'm your CodeMonkey. In this lecture we're going to begin synchronizing some proper game logic by handling the delivery manager. Okay, so for our first lecture synchronizing the game logic, let's begin with the simplest one, which is really just the delivery manager. So here we have the game playing right now. We have two players connected, the movement and the animations, all of it is being synchronized. But for example, over here on the recipes, note that each client is generating their own recipes. That is not correct. We only want the server to generate recipes, and we want all clients to be seeing the exact same recipe waiting list. Then we also want to synchronize whenever a player delivers a recipe, either correctly or incorrectly. And again, here we have to answer the same question as always, do we make the server auth or client auth? But before that, let's start from the beginning. Let's first go up here onto the delivery manager script, and as usual, let's swap out the mono behavior for a network behavior. And let's go ahead and add unity.netcode. Then over here in the editor, let's find the object with the delivery manager. And as soon as we select it, yep, we've got the nice window. So let's go ahead, click on yes. And there you go, it does have the network object. So back onto the delivery manager. Like I said, we only want the server to generate recipes. The other clients should just receive the recipes from the server. So let's go down here and where we have the update, where we count down the timer and spawn the recipes. Over here, we want to make sure this logic only runs on the server. So like we saw, if we have a network behavior, we've got all kinds of is properties. In this case, for running things on the server, we can ask is server. So if this one is not the server, if not, then we just return. Okay, so let's do a quick test. And yep, both the host and the client, both of them are connected, but only they're the host, only that one is generating recipes. Okay, so far so good. Now all we need to do is really just synchronize the spawned recipes so that the client knows about them. And for that, we basically have two options. We can use RPCs or we can use a network variable. Both are valid options. I covered them both in detail in the netcode video. The one big difference between them is mostly related to late joiners. So if a player joins late, they will receive the current state of a network variable, but they will not receive the client RPCs that were sent before that time. This means that it is actually very important for you to decide whether you want to allow late joining in your game or not. That is a very important decision that will decide how you implement certain features. For this game, this is a simple game with a short session duration. Each game session is really just only about 2 minutes. So for this game, I'm going to decide to not allow late joining. So all of the players join in the beginning of the game and they play until the very end. No player can join the middle. Making this choice really helps cut down on the complexity needed to make this game. And near the end of the course, I will have a lecture talking about this difference in more detail and what you would have to change if you wanted to enable the game to support late joiners. The main takeaway right now is that this is a very important question you need to ask yourself when making your game. In my case, like I said, for this game, we are going to not allow late joiners. So for synchronizing this data, we're going to do it through the simpler RPC method. Although also, don't be confused, RPCs and network variables can both be used regardless of what you choose. It's just that in a design that is meant to support late joiners, you probably want to use network variables more often, but even if you don't want to allow it, you can still use network variables just like we will use later on in this course. Okay, so with all that said, let's implement the synchronization with RPCs. Back in the delivery manager, over here on the update, basically the server is generating all of the recipes. And when it does, we want to tell the clients that this specific recipe has been generated. So let's make a client RPC to tell the clients to spawn a new waiting recipe. So let's go up here, make a new function, private void. Let's call it spawn new waiting recipe. And as we know from seeing the other netcode for game objects video, all the client RPCs must end with client RPC. So let's end this with client RPC. Then to make this an RPC, we also need to add the attribute, so client RPC. And finally, the goal is to spawn a new waiting recipe, so let's receive the recipe SO that we want to spawn. So this is the waiting recipe SO. Again, remember the RPC rules that I covered in the netcode video. So first one is make sure the name ends exactly with client RPC. So it has to be like this, it cannot be in lowercase and so on, so it has to be exactly client RPC. Then make sure you add the attribute. And also remember how the client RPCs actually work. Basically, the server will call this function, so up here when we generate something, we are going to call this and pass in the waiting recipe SO. So the server itself is running this code and calling this function, but in reality, this function will actually run on every single client. Also remember that the host acts as both a server and a client, so the host will be running the code up here and also the code over here for the client RPC. So up here, we trigger the client RPC to spawn the recipe, and then down here we just do our local logic. So we add it to the list and we fire off the event. Okay, so this looks like valid code, we have no errors. However, if we go back in the editor, yep, here in the console we do see a bunch of errors. This is also important. Server and client RPCs have various rules and validation which does not run on Visual Studio, but it does show up over here on the console in the editor. So when you make an RPC, always check the console to make sure you didn't break any of these rules. For example, this rule here is telling us that the netcode library does not know how to serialize our recipe.so object. Basically, for RPCs, we can only synchronize value types, or we have to tell netcode how to serialize them. The more complex option is to implement iNetwork serializable. I covered that in the netcode video, but a much more simple option is to just use a type that can already be serialized. For example, over here on this script, we already have a recipe list.so, and for deciding which one is going to be the waiting recipe, we are really just randomly generating an int, so generating a random index. So we can just modify this code so that instead of sending a recipe.so, instead of that we can just send the index of where it is on the list. Since all the clients have the exact same list, by sending the index, we're actually going to be able to get the exact same SO. So let's do that. So over here, instead of a recipe.so, let's receive a parameter of type int. This is the waiting recipe.so index. And then up here, let's also define that. So the int for the waiting recipe.so index, and we do our random.range, so the usual stuff. Then we pass in this as our parameter. And then down here, we can simply get the waiting recipe.so by just going into the exact same array and grabbing it from there. Okay, so that's it, very simple. Again, remember that the host acts as both a server and a client, so the host will run both the code up here as well as the code down here. So importantly, make sure you only add this local code, adding it to the list and spawning the event. Make sure you only add this one down here and not also down here as well as up here. If you add it in both places, then the host will end up spawning 2 recipes every time. Now, before we test, let's just go up here for the spawn recipe timer. Here, this one starts off at 0 and we count down, meaning that literally on the first frame, it is going to spawn right away. Let's add a bit of time over here, let's say for F. This is just so we have some time to press the host and the client buttons before anything is actually spawned. Okay, so with that, let's test. So up here, let's connect the host, down here the client, and now let's wait a little bit and see if the recipe is spawned. And yep, there you go, that one spawned the recipe, and yep, that one did get the recipe synchronized. So it spawned that one and then that one, so they both have the exact same recipes. And if we wait a bit, yep, both have the exact same max amount of recipes. Alright, awesome! Now here let me make one point. Later on in this course, we're eventually going to synchronize the game start, the game countdown, and so on. So when we do, this code will work perfectly. But right now, you do need to make sure that you connect the host and the client as quickly as possible. If instead I connect the host here and I wait 4 seconds to spawn a recipe, so just wait a bit, that one is spawned, and now I connect down here on the client. If I do that, then yep, look how now we have 2 recipes, but down here only 1 recipe. So this is a good example of the difference between network variables and RPCs. Basically, this client joined late, so because of that, it missed the RPC spawning the first recipe. But again, like I said, for the design we're going to do, this scenario where the player joins late, this one is never going to happen. Just make sure that during testing, you click on host and then on client as quickly as possible so you get the actual proper behavior and not just a testing bug. Okay, so now that we have the spawning synchronized, let's handle the delivery. If I go on the host and I just try delivering something right now, there you go, only that one receives it. This one down here has no idea something was delivered. So we need to synchronize the actual delivery. Back in our delivery manager, let's go down into the function. Here it is, the deliver recipe. Here we are going to have the exact same question as always. So do we make this server auth or client auth? Meaning, do we validate the delivered plate on the client, and then the client tells the server whether it was a correct or an incorrect delivery? Or does the client pretty much only send the plate kitchen object, and then the server validates the contents? Again, for this co-op game, let's just trust the client and go with client auth. So the client is going to run all of this logic, and then down the end it will tell the server whether it was correct or incorrect. In this case, we want the client to tell the server, so instead of a client RPC, we're going to use a server RPC. So let's go up here, make a private void, deliver correct recipe, server RPC. And we're going to add the attribute server RPC. Okay, this is it. However, this will only run on the server. Again, remember the very, very important differences between server, host, and client. If we do it just like this, and I copy the code, so the local code for delivering the correct recipe, and I just put it like this. If we do it like this, then only the server will run this function. So if you do it just like this, the client will not know that the recipe has been delivered. So always remember those 2 types, server and client. Basically, we want the client to tell the server that it delivered a correct recipe, but then the server needs to broadcast to all of the clients that that behavior just happened. So when the server receives a server RPC, we then need to send a client RPC to broadcast that message to all the clients. So let's go down here, make a private void, deliver correct recipe. This time it's a client RPC, and we mark it as a client RPC. And then it's down here that we do the actual behavior for actually delivering the correct recipe. So then on the server RPC, it just calls the client RPC, which again, remember how this runs. Remember how the host is both a client and a server. So if we run this on the host is going to run this function, and then the host is going to run this code, and then the host is also going to run this one. Whereas a client is going to call this function, but then the client itself does not run this. The server runs this, calls the client RPC, and then the client will also run this function. So with this, the logic should be working correctly on all of the correct places. We just need over here, we need the index. So this is the index of the recipe that has been delivered. So let's just add it over here as a parameter. Since it's an int, we can use it on a server and a client RPC. So let's just find an int for the waiting recipe SO list index. And up here we pass in the I. Then we pass that one in onto the client RPC. And then we just use it over here. Okay, so the correct delivery has been synchronized. Now let's do the exact same thing for the incorrect recipe. So let's do a private void deliver incorrect recipe for the server RPC. And then we're going to have another one, but this one is going to be the client RPC. Then let's set the attribute, so client RPC, and up here we've got the server RPC. Then the server is going to call the client RPC to deliver the incorrect client RPC. Yep, just like this. And then on all of the clients, we're really just going to fire off this event. So just like this, and we're going to trigger the server RPC up here. Okay, so that's it, some pretty simple logic. As long as you understand the flow for how the server RPCs and the client RPCs work, as long as you understand that, then all of this is pretty straightforward. So let's do a test and see if this works. So up here on the host, let's deliver a correct recipe. So let's make a quick burger. So just put that on the fryer. Let's grab some bread, pick up some plates, pick up the meat, pick up the bread. And now if we go ahead and deliver it, and if there you go, it does work. Both of them saw a delivery success and both of them removed it from the recipe list. Okay, that's great. But now down here, if we do it on the client, so let's try to deliver a cheeseburger. So let's pick up some meat, cook it. Let's pick it up. We just need this. And let's try delivering it over here on the client. And nope, over there we have an error. This error has to do with ownership. And just like it says, only the owner can invoke a server RPC that requires ownership. Since the delivery manager belongs to the server and not the client, that means that only the server can trigger that server RPC. That is the default behavior for server RPCs. They can only be called by who has ownership. And to solve this problem, we actually have a very simple solution. Over here on the server RPC attribute, we can have some optional parameters, and one of them is down there, the second one, the require ownership. So we can set require ownership equals false. And this way, the server RPC no longer requires ownership in order to trigger the server RPC. That means that the client that does not own this network object will be able to trigger this server RPC. So let's do this both up here on the incorrect recipe and down here on the correct one. Okay, so just with this change, let's test. So down here on the client, let's try to deliver a salad. So let's pick up a tomato and just slice it. Then pick up some cabbage and slice it. Pick up some plates, put both of them in there, and let's go ahead and deliver. And if there you go, delivery success. All right, awesome. Now let's try delivering a failed recipe. And yep, that one also works. And up here on the host, deliver a failed recipe. Yep, also works. And now a success, so let's cook a nice burger. Now let's go ahead and delivery correct, and if there you go, delivery success. Alright, awesome, so we have every logic working. Now with this working, let me just quickly talk about how you could make this system server auth. The answer is really just like I mentioned a while ago. So over here, instead of running the validation here and then telling the server whether correct or incorrect, instead of doing that, the client would simply tell the server, I want to deliver this plate kitchen object. Then the server would check the contents of the plate and basically validate them. As long as you make every step of the process for adding ingredients onto the plate, as long as you make all of that server auth, then the entire logic would be fully server auth. But again, in our case, for our simple game, let's just stick with the simpler client auth. So here the client validates the plate and then just tells the server whether it was correct or incorrect. Then the server receives that RPC and simply broadcasts the message to every single client. Okay, great. So over here we handled synchronizing our very first custom game logic. To make our game fully multiplayer, we really just need to apply this same process to every other part of our game. But before we get to synchronizing some more things, let's quickly fix just one minor thing. When we first converted this game to multiplayer, we had to get rid of the player singleton, which in turn broke the selected counter visual, so let's fix that in the next lecture.